So we got three masses being pulled by a 42 Newton force. This 42 Newton force, one thing you got to realize in this problem is this 42 Newton force here, does it know that it's pulling three masses? No. It doesn't know. What does that 42 Newton force know? It's pulling what? 6 kilograms. And what makes this problem particularly nice is they tell us that it's on a frictionless surface. I mean, could this problem have been made more challenging by adding friction? Yeah. So then you'd have frictional forces acting opposite motion, but there's no friction here, which makes it a lot easier. Okay, so how do we do part A? So we're told we have a 42 Newton force acting on 3 blocks. Determine the acceleration of the system. So what do we mean by the system? The whole thing is the system. What's the mass of the system? 6 kilograms. So here's how you do part A. The best way to do part A, here is the system. The mass of it is 6 kilograms. So what are the forces on the 6 kilogram system? Well, we have mg down. We have normal force up. We have tension. Well, that 42 Newton force. We'll just label this 42 newtons. Now I'm going to tell you right now, in this problem, the vertical is not going to matter at all. We're never going to use the y direction. It's not going to factor into our solution. So I only have about 6 minutes to do this. So I'm only going to show the summing of the forces in the x direction. So part A wants us to find the acceleration of the system. So here's our free body diagram. What do we do after the free body diagram? We sum forces. And we're only going to do the x direction because that's where the acceleration is. Is this system going to accelerate in the y direction? No. The acceleration's in the x. All right, so what's the only x force? There's only one. 42 newtons. So that is the sum of the forces. There's only one. That's the sum. So what is it equal to? ma, where that's our x acceleration. So there's our sum of the forces. So now we take this, solve it for A. So A is going to be 42 newtons. And remember, what's a newton? Kilogram meter per second squared. That's a newton. And then the mass is 6. So then kilograms cancel. And then this comes out as 7 meter per second squared. So that's the answer to part A. The acceleration of all 3 masses, the acceleration of this guy, and this guy, they all have the same acceleration because they're all connected together, right? So that's going to be important. All 3 objects have the same acceleration. All right, can I go to part B? Okay, so I'm going to erase part A. Okay, part B. What do they want? The tension in the cord connecting the 3 kilogram and the 1 kilogram. All right, so we're looking for the tension in this cord right here. Now, you could either find that tension by focusing on the 3 kilogram mass or by focusing on these 2 guys together, right? Because the rope is connected to both of those objects. Okay, so let's do it both ways, just so you can see how to do it. So let's start by focusing on this left system. All right, so here's the free body diagram. So what's the mass of this total left guy? 3 kilograms. Okay, so what's the free body diagram? We got mg down, we got normal force up, and then we have tension to the right. Okay, now what if we focused on this guy? So I'm going to do this guy up here. So what's the free body diagram for that guy? Well, it's going to be different. So here's this guy, 3 kilograms. So the forces are mg down, normal force up, and then we have 42 newtons to the right, tension to the left. Isn't the rope pulling to the left for this guy? Yeah. So the free body diagram is super important. If you don't get these free body diagrams correct, you can't get the question right. So you really got to get good at identifying the forces. Okay, so let's sum the forces for this guy down here. And both approaches are going to give us the same answer. All right, so summing the forces in the x direction for this guy, what's the only x force for this guy? Tension, that's it. What is it equal to? ma, right? So T is going to equal ma. What's the mass? What's the mass of this guy? 3. And the acceleration is 7. We already solved for that. So tension comes out as 21. Now, what if you would have done it for the other guy? What if you would have focused on this guy? So here's what you would get. So looking at this free body diagram, you sum the forces, you get 42, so this is x direction. 42 minus t equals ma, right? That's the sum of the forces for the x for the right guy. Now, take this, solve it for t. You're going to get 42 minus ma. Mass is 3. A is 7. So this comes out as what? 21. So you get the same answer either way. Yo.
Why is it 4 kilograms?
Huh?
Why is it 4 kilograms?
Which one?
Because it says 3 and 1 kg block.
The 3 and the 1. Oh, well, because the rope is connected from the 3 kilogram to the 1 kilogram. But look, so looking at the left here, is the rope pulling only the 1? No, it's pulling the 1 and the 2.
Oh.
So it's pulling 3 kilograms.
Oh.
Okay. All right, last question. What's the force exerted by the 1 kilogram on the 2 kilograms? So I got to make some room here. This is getting messy. Okay, so which guy are we focusing on now? The question says this: the force exerted by the 1 kilogram on the 2 kilogram. Which guy are we focusing on? The 2 kilogram guy. We're focusing on this guy. So let's do a free body diagram. So here's the 2 kilogram guy. What are the forces on him? Well, mg down, normal force up, but the vertical is not going to matter here. Okay, what's the x force? It's the force of the 1 kilogram on the 2 kilogram. What's pushing the 2 kilogram block? The 1 kilogram block, and that's this F right here. So we're looking for this F. How do we find that F? We sum the forces. F equals, so there's mass times acceleration. So the force pushing the 2 kilogram block, you're going to go F equals ma. What's the mass here? 2. What's the acceleration? 7. So this comes out as 14 newtons.